Hello, welcome back. It is another video, and today I'm going to be showing you how I'm dealing with roads and pathways and stuff in Prismatica. So, let's jump straight in. You can see I've been working on all my props and, getting everything all donezo and whatever. But, on top of that, I've been messing around with my road spline system, or systems. Before we take a little look under the hood at what's actually going on here, you will need to know a few little things. So you'll need to know how to set up a runtime virtual texture. You'll also need to know about height lerp, which I have a video for here. As a little extra bit of fun, we do some grass occlusion using my runtime virtual texture Grass Occlusion method, which is linked here. And I guess you'll probably need to know how splines work, but I will show it all on the screen. And if you want to copy it, then you can copy it. And lastly but not leastly, I forget what number I'm up to. You'll need to know a little bit about custom data. So there is a video here about custom data and how it works and why it works and what it does. Back to the roads, and you can see that it's actually it's up in the air. It doesn't matter whereabouts it is, up or down, because we're not actually rendering the object at all. We're only printing it to the runtime virtual texture. Basically, the way this landscape texture is set up, the bulk of it here, which is, all the colors and the textures and the blah, 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 they all get done here, but then they get put into a runtime virtual texture. Instead of going straight to the make material attributes, or the material output or whatever, they go into the RVT. So they're getting written to the runtime virtual texture, and then within the same material, we sample that runtime virtual texture, and so we pop it all out into here, basically. So let's just, for simplicity's sake, we'll say that the landscape is all green, and then the output here is just, the color. So that's basically how the landscape needs to be set up. It needs to be using a runtime virtual texture, it needs to be writing to and reading from an RVT. And so what that kind of does is it offloads all of the landscape, shader code, writes that to a texture, and then it just reads from that texture from then on. Now, the benefit of doing this is that we can actually print things to the landscape's runtime virtual texture. So in this case, we're printing this road to the landscape. So the way that this spline is set up, it's all done in the construction script. And essentially what we do is, on construction, we create a dynamic material instance. This part isn't completely necessary unless you're changing the texture value and stuff. If you were just using a material instance, per road type, then you would be absolutely fine just, just leaving this part out and just having a material assigned to the spline. So then we get the number of spline points, -2. We do a for loop from 0 to that indice. Then we loop through them all. We add a spline mesh component, which looks like this. It's just a grid, just a plane that can bend and deform and that kind of stuff. And then, set forward axis for each of these, set the start and end. We get the location, the tangent, scale. You guys can probably just copy this if you want. I might even paste bin all of this in the description, so keep an eye out for that. So basically, this is just setting up a spline. Then we set the material on each spline point to be this material here that we created at the start, which, again, you don't have to do that if you're not changing any of the parameters on construction. And then lastly but not leastly, we get the spline points at the start, so spline point 0, and at the end, and we set some custom data floats on them. Ooh, spicy. This is a really nice trick that I figured out that just makes everything so much nicer looking. So that's how the spline itself is set up. Again, I will paste bin it in the description. So let us now look at the spline material, and we'll have a look at what it's actually doing. You can see that the actual material output here, it has, well, nothing going for it, basically. A blank material with 0 opacity, you know, it doesn't exist. If we were to put opacity in it, then you would see that it's just a, you know, it's a strip. But the meat and potatoes of it happens over here, where it gets put into Runtime Virtual Texture output and then written to the RVT that the landscape is sampling. So one of the cool things about printing to Runtime Virtual Textures is this opacity input. You can see that if I just put the opacity at 1, then this wouldn't have that nice fade out that we love. It's just like, it's all printing to the damn thing. So by using this opacity input, we can actually, you know, put gaps in what we're printing and all that good stuff. And as well as the opacity, we get the inverse of that, or the 1- of that. You might not need to 1- it depending on how you've got it set up, but this goes into the roughness channel, which we're using for the grass occlusion. So you can see that, you know, there is grass, but you can see that wherever there isn't brick, even when there's just like little gaps and stuff, the grass pokes up through it. And you know, it's kind of cool. So the other cool thing that I'll show just before we get stuck into it proper, you can see here I've got a custom data float of index 0 called start, and a custom data float of index 1 called end, and I've just got a random color in here. And if I just put this into the base color, then you can see that the start point is white and the end point is, well, orangey, red, something. So this way we can differentiate which is the start and which is the end piece. And you can see here that I've actually got the bricks trailing off into nothingness. So how do we actually get our pathways to look this fantastic? Well, the answer is using height lerp. Basically, all we're doing here is we have a texture called road texture. This one is just a texture of a road, and it goes in this direction. Pretty self-explanatory. And we have some tiling parameters here. We can tell it to tile more or less. Keep in mind, when you are doing the tiling and stuff, it does need to be an integer or a what do you call it, you know, half of 1 or a quarter. You can see here that there's a cut in the texture because it's not an integer, it's not integerial. Whereas if I put this up to 2, then it's seamless. That's how textures work. And then we've got the tiling in the other direction. This one doesn't have to be an integer, but you know, it just basically says, hey, how thick do we want these bricky boys to be? So that's that little bit there. I pack my height map, or you could call it a displacement map. Mine's packed into the B channel. You might need to, you know, if you're using like proper textures and stuff, have a separate sample with the same UVs for your height map. You'll have a few textures. I just have one texture, which is a normal map and a height map. So what I'm going to do now, I'm going to get this height map, and we're going to put this into the actual, like the meshes texture and stuff, just so we can see what's going on. So you can see here, we've got our height map. Now, what do we do with this height map? Well, we use a height lerp. So this is the texture input, so texture -1, and then we have our height blend value multiplied by 2, add them together, do some contrast, and as we go from 0 to 1 here, you can see it's going to reveal the highest parts of the height map first, so like the tops of these bricks. So this by itself looks, you know, it's getting there. A little bit dodgy. So the way that we get this to fade towards the edges is we get a linear gradient, we saturate it just, you know, for safety. Then we're going to 1 minus it, and then multiply that by itself. So what this is going to leave us with is a gradient from one side being black. It's going to be grey in the middle. It's going to be black on the other side. And then we have two parameters called road fall off offset and road fall off hardness. So if we plug them into here, and you can see as I start playing around with these, you know, we can create a gradient of sorts. You know, if the hardness is harder, it will, you know, be brighter in the middle. We can use the offset to kind of, you know, determine how thick or thin it is, or, you know, if we have a low hardness, but then a high offset, we can get something that's like, you know, a smoother gradient from side to side. And then on top of the, you know, side to side, like fall off values, we also have a start and end fall off value using the custom data that we set on the spline for the start and the end points. So what this is doing is, if I just go into here and I go end fall off hardness, so you can see here that we end up with a gradient at either end. One of them goes this way, one of them goes that way. And the way that we actually create that is by just getting another linear gradient, this time in the U direction, so like along the path. And then one of them is going in this direction, multiplied by, you know, this custom data. It's basically just a lerp from 0 to 1 saying, you know, is this the end piece? And this one's asking, is this the start piece? And, you know, it has the inverse, the other direction of the gradient. And then we just add them together. We multiply them by what's the fall off hardness, so how strong does this gradient need to be? And then we subtract that from this. So then what we end up with, this kind of shape here. So we've got, you know, from one end to the other end, there's a gradient, and then we've also added this one here from, you know, the end point, blah, blah, blah. And, you know, this is what we're ending up with. Very cool. Then as an extra layer on top of that, we just have some noise. This is some world space noise. It's pretty big. And then there's a parameter called noise influence. That gets subtracted from the result there. So let's just plug this in, see what it does. Noise influence. Okay, so you can see here, it's just adding noise to this thing. So, you know, if we want something that looks like it's kind of all broken up and whatnot, or it's, you know, very worse for wear, we can add noise to it. And that's going to help with making it a bit more believable. So you can see, like, over here, I have this circular pattern, and I've just, you know, I've pumped it full of noise, and it looks pretty ripper. So that's basically just there to kind of break up the tiling a bit so that it looks a lot more natural. So we're getting to the pretty spicy part of this, and that is determining the colors and stuff. So up until this point, we've been creating our kind of final height map. And so then this gets split into two parts. One of them decides the color, which has an offset and a contrast, and then one of them decides the actual, like, opacity of the road. So this one here, it's called dirt offset, dirt contrast. It's just going to lerp between the color of the road and the color of the dirt or something. If we go to the dirt offset value, we can say, okay, well, the dirt needs to come up higher, the dirt needs to go down, you know, lower. We can adjust all of that. Then we can also adjust the dirt contrast. So if I put this up to like 100 or 62,000, apparently, you can see that the transition between the stone and the dirt is like, you know, it's super hard. Whereas if we turn this down a lot to like 1 or something, it's like a smoother gradient. So you can see as I turn this up, yep, put it down, yep, cool. So this is just a stylistic thing. I like to keep mine at like 10-ish. And then, very similar to that section, we just have the road's opacity. So this is the opacity that's getting drawn to the Runtime Virtual Texture. It's also what goes into the Grass Occlusion. If I put this up to, you know, 1 billion, then it's like very, very hard. If I put this down to, you know, 5 or 1 or something, you can see that it's a lot kind of smoother in the way that it blends into the ground. Now, one last thing that I do, I actually use the specular channel of my Runtime Virtual Texture as a height map for, you know, the actual landscape. So I can pass through the height map and use that for some cool landscape effects. But the cool thing about this is that we can actually write the height map of the road onto the landscape. So if I was to get my weather effects, I have some like pretty cool weather effects, you know, in my landscape and whatnot. If we were to get my puddles and start, you know, doing puddles as though it was raining and whatnot, you can see that the height map of the road is actually taken into account. Now, like, this isn't a 3D effect at all. This is just all completely fake. But you can see that it, you know, it definitely adds a lot more depth to it, I guess. It's just really cool being able to access the height map in the RVT if we need to. So that's just a fun little bonus. So I believe that is everything. I believe that's the entire road, Spline, Material, Prismatica, TM, Advanced, Enhanced, Spline road system thing. Nothing too special. I'll paste bin this for you guys if you want. There is another really cool thing that I did, which is probably a little bit out of scope for this video, but it's this kind of radial tiling material thing that, you know, uses the same thing, like the height map and the blah 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 blah. All of the bricks are like the right length and whatnot. And the way it works is we get the text coords, offset it by half, we do vector to radial value, and then we actually break it up into segments using some quantization. So, you know, you've got to know how many bricks are in the, like, how many rows of bricks are in the texture. And then we can adjust the other text coord by that, you know, by like which row it's in. So if I was to just get this and put it in there, and, well, I guess the G is just already in there, then you'll see why this could easily be an issue if you were trying to do this any other way. So you can see in here, the bricks are like, they're the right size. But as we go further and further out, they just get stretched and stretched, because that's kind of how the radial vector thing works. So the cool thing about this is that it breaks it up into like individual rows, and then it makes each row tile more than the last row, and basically fixes all of the stretching. And this can be, you know, as big as we want it to be, but, you know, I don't want to go out of scope for this video, so I'll put it in a paste bin. You guys can study it. If you want, I'll do a little explainer video, just like a short 5-minute video that kind of goes over this as like a part 2 to our pathway and whatnot. So one last thing I wanted to add is that you could put the height map into a virtual height field mesh, I think they're called. Or if you're still using tessellation, you could feed the height map into, you know, one of the channels on the RVT, and then use that to do some tessellation stuff so that the bricks and whatnot actually stick out of the landscape, rather than just relying on normal maps and that kind of thing, like I do, because it's a top-down game and whatever. But if you did want some parallax or something, you could use, you know, parallax occlusion mapping using the landscape's global height map, or displacement tessellation, or virtual height field, height map, whatever they're called. I don't know what I've never used it, but there are a lot of ways to kind of take this to the next level, which could be cool. But aside from that, that's the video. I hope you learned something. Hope you find it useful. As I said before, I've left both of these materials and the Spline setup in a paste bin in the description. So Feel free to use these. Don't have to give any credit or anything like that. But if you do want to go one step further in supporting the channel and the tutorials and all the good stuff, you can do so for as little as $1 per month through the Patreon, which is linked in the description. So get on it, please. Please. Anyway, with that I say goodbye. Goodbye.